And we are live. Hello, guys. Welcome back to Code and Create with me, Joe Davis, and Orbis Connect. Hope everyone is safe and well and enjoying the slight ease of lockdown. We've been able to go to a pub and get your hair cut. I know I certainly enjoyed that. So following on from last week, if you did join us, we had Niraj with us last week. It's the first time we're doing a double session. So, yeah, really excited for this. Niraj last week spoke about more of an intro into Apache Spark, the foundations of Apache Spark. And this week he's going to be going into a bit more technical depth around the data analysis of Apache Spark. So we're going to be chatting with him for about 30, 40 minutes. He's going to be doing quite a hands-on example of how to, or looking at data analysis. So really excited about this one. How are you, Niraj? Welcome back.
I'm doing good, thank you, and thanks for providing again me an opportunity to be here and share my knowledge with a wider audience. How are you doing, Jack?
Yeah, not bad, thank you, Niraj. Not bad. It is absolute terrible weather where I am at the moment, so that's not usually a good thing. But anyway, if you've got any questions for Niraj, guys. If you're watching on Crowdcast, you can use the Ask a Question button below, and we'll try and get around to all the questions at the end. We had quite a lot of questions come in last week. We just managed to squeeze them all in within the hour. So, so do get them in, and we'll try and get round to them. If you're watching on LinkedIn Live, then please do put your questions in the comments. We'll try and keep an eye on that as well, and we'll try and get round to all them. Let us know also where you're tuning in from, guys. It's always nice to see where everyone is tuning in from. We have loads of different locations usually tuning in from the States, Europe, India, Malaysia. It's really nice to see. So yeah, let us know where you're tuning in from. Niraj, just for the benefit of the people that weren't on the call last week, can you just give us a bit of an intro into yourself and your background?
Yeah, absolutely. So myself, Neeraj, and I have more than a decade of experience into the industry. And currently I'm working at Expedia Group as a data scientist and focusing more on machine learning and the data science side of it.
Fantastic. Right, so let's get cracking, Niraj. You're going to share your screen and we'll go through the presentation, and then we'll get get to all the questions at the end, yeah?
Yeah, absolutely. Let me try to share my screen and okay. So can you please confirm if you're able to see my screen?
Yeah, it's all good, Niraj.
Okay, great. So first of all, I would like to welcome everybody and thanks for joining for this particular second session of this particular series. In the previous session, we discussed about the Hadoop ecosystem. We discussed about the architecture of Spark and also anatomy of the job into the Spark. And we discussed about the RDDs, which stands for the Resilient Distributed Dataset. Now, in this particular session, we will specifically focus on the Spark SQL API of Spark, and we will discuss how it works and how we can use to perform the data analysis using the different data sources. Now, to start with, I will start with the definition or the discussion with the certain terms. The first one is, let's say, the data frames. So data frame is nothing but it is pretty similar to a relational table. Okay, and if you have worked with either Python or R, you might have already familiar with the data frames. So it looks pretty similar to our relational tables. What is Spark SQL? It's another module which is provided by Spark for the structured data analysis. So in the previous session, we discussed about the Spark core. And in this particular session, we'll discuss about the Spark SQL, which is being used for the structured data analysis. And the third one is Spark Session. So Spark Session is the starting point of our Spark applications. Prior to 2.x, we used to have the different sessions like Spark Context. We used to have different contexts. For example, the Spark context, the SQL context, Hive context. And the purpose of the different contexts was different. But what they did with 2.x onwards, they have unified all the contexts and they have created a Spark session. which can be unifiedly used across the different type of Spark workloads. Now, to start with, so first of all, there will be no presentation in this particular session. It will be entirely hands-on. We will create some sort of dummy data frames. We will go through the operations which we can perform in the data frames, and then we will also discuss how we can use the different data sources like Hive tables, CSV files, and a few other in this particular session. And I would request, if you have any questions, as Joy mentioned, please post your questions and we will try to answer the questions maybe during the session or at the end of the session as well. Okay, so, and also in terms of the infrastructure, what I'm using, so I'm using the GCP, which is the Google Cloud Platform's Dataproc, which is the managed Hadoop platform. And I'm using Jupyter Notebooks in order to run my Spark code. However, if you want to run your Spark codes, there are a variety of ways to do that. You can use any particular IDEs, or you can use various other notebooks available. For example, the Jupyter, which I'm using, or the Zeppelin notebooks, or the Databricks notebooks, or you can use Spark Shell, which is the command line provided by Spark, or you can use any particular IDE. For example, for Python, you have various IDEs you can use, or for Scala or Java, you can use the other IDEs as well.
I assume that you use Jupyter for certain reasons. Would you say that that's the best notepad to use?
So, I mean, the different notebooks have their own advantages and the own, I would say, pros and cons. Like here, I'm using Jupyter Notebooks because the one main reason is I'm using the Python API out of the various APIs which are available, and I think Jupyter is one of the most widely used notebooks for the Python. So that is the reason I'm using the Jupyter Notebooks. However, the code which I'm running, which I'll be sharing, if you can run on either on the Spark Shell or on the Jupyter Notebooks, Zeppelin Notebooks, Databricks Notebook, that should work absolutely the same. Okay, so let's get started. So to start with, what I will do is I will load certain libraries which I will going to use throughout this particular session. So the first one is I'm loading the Spark session because I would like to create a Spark session. Then I'm loading the functions module because it provides a lot of different functions. And then I'm loading the types because it provides the different types which we will be going to use throughout this particular session. Next, what I'm doing is I'm creating a Spark session because this is something which is the starting point of our Spark application, as I mentioned. And then what I'm doing is I'm just enabling one flag for the eager evaluation. The reason is because I would like to use to display the data, to display the data neatly within the Jupyter Notebooks. So I will discuss when I will show the data, like what I meant. So it's just for displaying the data in a little neater manner. That's it. Now, the idea is, first of all, I'm going to create a data frame with some dummy data. So here, what I'm doing is I'm creating a list of certain tuples in Python, and I'm calling it a EMP and the department. So let's say that these are some dummy employee records. These are some department records. And what I'm doing is I'm creating a data frame. So I'm using Spark session, which we have created, and using the function create data frame, which will create the data frame. And here I'm specifying the data which we have created here. And then as a second argument, we are specifying the name of the columns which we would like to create for our data frames. So let me execute this. And what I can do is I can display the content of the data frame. And I can show you how it looks like. Now, first of all, what I can do is I can display the content using the show function, which is natively available into Spark. And when you perform the show function, what it will do is it will display the content of the data frame. By default, it will only display 20 records. So let's say if you have 1,000 records in your data frame, it will only display 20 records. However, if you would like to control the number of records which you would like to display, you can specify the number which you would like to see. So here,
So
what I'm doing
you
is,
can actually, sorry, you can actually see more than 20, but you just have to specify exactly how many you want to see.
absolutely. By
Right. Okay.
default, it's 20, but if you, let's say, 1,000, it will display 1,000 records.
I see. Yeah.
Since we only have, let's say, 10 records, so just for the display purpose, I will say 5. And you could see this is how my data frame looks like, which is pretty similar to a relational table where we have our data, and this is our header or the schema of our data frame. And here we could see, since we have provided a limit, we could see that it says showing only top 5 records.
Yeah.
If you have the more than 20 records, and if you don't specify anything, it will say showing only top 20 records. Okay, now, so far this looks okay, but let's say if we have more columns, let's say 15, 20, 50 columns, so this display might not work pretty well. So that is the reason I just enabled that flag at the top to eagerly display. And you could see now my data frame looks a little neater than before. So
Yeah.
different notebooks have their own different versions of display, but that's just a matter of displaying the data onto the console or the notebook. That's it. Now, let's discuss some basic operations before we deep dive into the analysis of the data frame. So let's say I have read the data and I would like to know, first of all, how many records do I have? So I can check with the count, and it says the 10 records. Now the next is I would like to see what are the different columns we have in this particular data frame. We have the columns attribute, and it will display the content. It will display the columns of what we have in the data frame. Now, at some point of time, if you would like to see what are the data types of a particular column, then you have something called as a D type. And what it will do is it will also display the data type of a particular column. So for example, at some point of time, if you would like to select only the columns with a particular data type, maybe you can use D types, and then probably you can do some filtering and you can extract only the data columns with a particular data type. But it's also like if you would like to check the data type, this is how you can do that. Now, how Spark will store the schema internally, because when we loaded the data, we haven't specified the schema. We just specified the name of the columns, and it has inferred the schema automatically. But what if we would like to control that particular schema and we would like to specify that schema? So in order to do that, let's first see how Spark stores the schema internally. So this is how Spark stores the schema internally. So if I talk about schema, which I would say this. So what is schema? It is nothing but a collection of attributes. So here, your schema contains 4 attributes: ID, name, department, and salary. Now, here, your schema is represented by an object of struct type. And if you look inside, your each attribute is represented by an object of struct field. So for example, your ID column is represented by this particular struct field object, where the first argument specified the name of your column, the second argument specified the data type of the column, and the third argument specified the nullability for that particular column. So this is how Spark stores the schema. And if you would like to specify the schema, probably you can specify the schema using the struct type and the struct field object. Also, if we would like, at some point of time, we would just like to display or check the schema of our data frame, we can use the print schema function, and we can do that. And here we could see that it's a little neater in a hierarchical manner. And we could see that we have the 4 columns, and these are the data types. This works specifically pretty well when you have, let's say, the hierarchical data set. So you can also see the hierarchy of the schema, and this will be pretty useful to check the schema for the hierarchical data as well. Now, so let's try to do some simple operations. So first of all, we would like to, let's say, select a particular column. So we have the data frame called as a EMPDF, and we would like to select a particular column, let's say ID and name, and we would like to show the content of that. So you could see the result is expected. And if you try to compare this with your SQL query, then you can say this is pretty similar to your select ID comma name from name of the table. So this is pretty similar to that. So if you would like to select a particular column, you can use the select function. Now, here we have referred the columns with simply as a name. And if you look, these are nothing but a string. These are nothing but a Python string. However, there are different ways by which we can refer to a particular column. And we will discuss one by one, and we'll also discuss why that is important. So in the first line, what we are doing is we are selecting a particular column ID, and I'm just limiting that to 5 just for the display. And here, if you look, I'm specifying the name of the column as a simple Python string. Let me execute, and you could see I got the result which is expected. Okay. Now, what are the other ways I can specify the column? So instead of specifying the column name as a string, I can specify the column name as a column object. And this is how you can refer to a column object. The name of the data frame within the square brackets, you can specify the name of the column, and this will be the column object. Let me first execute. The result will absolutely be the same. Okay. Now, let me show you the type of the ID which I have specified in the first select, and the type of the EMP DF ID which I have specified in the second one. And you could see the first one is simple string, and the second one is the column. Okay. And even to specify the column, there are different ways to do that. You can say the name of the data frame dot name of the column. This will also gives you the same result. Or you can specify, you can use the column function which we have imported at the top and specify the name of the column. This will also refer to a column object and gives you the same result. Now, why we have these? First of all, we should know these different notations. For example, if somebody else has written the code, and if you are familiar with all of these notations, you will be able to figure out that like how they are represented. But when you're using for yourself, when to use which particular, let's say, the notation. So for example, we have a column object, and we have certain attributes defined in the column object. Let's say to sort the data into a descending order. Now, that descending ordering or the descending attribute is specified in the column object. Now, if you try to apply that particular attribute onto the string here, you will not be able to do that because that is present under the column object. So the idea is, if there are certain attributes or the functionalities defined in the column object which you would like to leverage, then definitely you should go with the column representation. Okay. Otherwise, if you don't want to do that, you can also use the name of the string as well. Okay.
So just to cut in there a bit, Niraj, just based on something you said last week about RDDs being immutable, are data frames similar to that? Are they immutable as well?
Yes, that's a very good question, Joy. Absolutely, data frames are immutable because if you remember, the data frame sits on the top of the RDDs.
Yeah.
So under the hood, we have the RDDs, and since the RDDs are immutable, in turn, data frames are also immutable. Okay.
Of course,
and
yeah.
I also have an example to demonstrate that maybe in a couple of minutes as well.
Okay, cool.
Okay. So this is how we can use the select operation. Then similarly, we can use the filter operations. So I have kept the different notations. You can go through it as per your convenience. However, what I will do is here, I would say like the employee DF ID column is equals to 1. Give me only those records. So this is how your filter works. You can specify the filter condition, and you can specify the more than one filter conditions using the and or operations as well. So you can specify the multiple conditions as well. Okay. Now move on to this one. Now here, what I'm doing is I'm dropping a particular column. So what drop will do is drop will drop a particular column, and after dropping a column, it will return a different data frame, and I'm just displaying that particular data frame. Now we could see we have dropped the column, and stored the new data frame into a new DF, and we don't have any ID. Now, in terms, since the data frames are immutable, if I will say empdf.show, you could see the ID column still persists because the data frame is immutable. However, you can transform one data frame to another. So when you perform these operations, you need to store the result into another data frame to keep those changes. So this is how we can say the data frames are immutable. Now, let's talk about some aggregations. Okay. Now, in terms of aggregation, it provides the basic aggregated functions. And here, let's say we would like to do an aggregation based on the department. And you have the aggregate function, which will allow you to do multiple aggregation on the group data. So for example, we have grouped the data based on the department. It will return the group data. And on the same group data, you can use multiple aggregations using this aggregate function. And also, you can control the name of the columns which you would like to display. So let me just show you. So you could see we have grouped the data based on the department, and then within the department, we could see how many number of records. So for example, in the department 5, we only have one record. This is the total number of salary. This is the maximum salary in department 5. This is the minimum salary. Since there's only one record, they are same. So the idea is this is how you can perform the aggregations on the data frame. Now, if you want to perform the aggregation on the entire data frame without grouping a data frame, you can directly perform an aggregate function, and you can perform a global aggregation on your data frame like this. Okay. Now, another important aspect is the sorting. So I'll quickly show you. So let's say if you would like to sort the data based on a particular column, you can specify like this, the name of the column, and you can say show. So what this will do is this will sort the data based on the salary. However, if you would like to, if you want, you can sort the data based on the multiple column as well. Let's say we would like to sort the data first based on the department, and within the department, we would like to sort the data based on the salary. You can specify the list of the columns within the sort function. And now you could see first your data is sorted based on the department column. So we have the department 1, 2, and 3. And within the department, if you see, your data is sorted based on the salary. So this is how you can do the sorting based on the multiple columns as well. If you would like to use the sorting based on the descending order, you can use the DESC function. So here what we are doing is we are sorting the data based on the multiple columns. And for the first column, we are sorting the data based on the ascending order, which is default. And for the second column, we are doing the sorting based on the salary in the descending order. So you could see again, my data is sorted based on the ascending order. And within a particular department, the data is sorted in the descending order. So this is how you can perform the sorting. Now, at some point of time, let's say we have certain columns, and based on the existing column, we would like to generate some other columns, which we can say the derived columns. How we can do that? So we have a function called as a with column, in which we can specify the name of the new column and then the expression of the column based on which we would like to create a new column. So let's say I would like to give a bonus to the employees, and the bonus is 10%. So how I can calculate? I can just select my salary, multiply by 0.1, and that will give me like how much bonus I would like to give. And you could see it has created another column. This is a very simple expression. However, you can write a very complex expressions as well to create some of the columns as well. And if I show you the name of the columns, definitely we have the bonus as well. Okay. Now, so far we have only used one data frame, but let's say we have the multiple data frames we would like to join. So I will be discussing various type of join. However, they are pretty similar to our relational joins. So would not like to go into the detail, but would like to show you how it works here in Spark. So for example, if you would like to join the employee data frame and the department data frame, so you can use the join function And in the join function, you can specify the name of the other data frame as a first column. And then as a second argument, you can specify the condition based on which you would like to join the two data frames. And since we haven't specified any type of join, like which type of join we would like to have, it will perform an inner join. Okay. However, if it will perform the inner join. However, if we would like to perform other type of join, let's say the left outer join, right outer join, or the full outer join, we can specify that as a third argument. So here, let's say I would like to do a left outer join. So I can specify third argument as a left outer. And you could see there was one record corresponding to which we don't have any department in the right. So we got this particular record and corresponding null values for the. So here for the right outer join, we have the null values for the left table. And if we do the full outer join, so we will have all the records from the left side of the table and the right side of the table. And you could see this record is present onto the left side of the table. This is why the right side of the columns are null. And this record only present on the right side. This is why the left side of the records are null. So this is how you can perform the various types of joins as well.
Niraj, just quickly, so I mean, is there any sort of performance difference between the SQL and data frame APIs at all?
So that's a very good question, Joy, and this is exactly the next section which we will going to talk about.
Okay.
So yeah, you are right on time.
Well, I did see the SQL queries bit come up, and I thought, and it sort of triggered my brain to ask the question. But apologies for jumping the gun there.
No, that's absolutely a good question, and I will definitely talk about that as well. Since we are talking about that, this is a Spark SQL, and it provides the SQL-like capabilities, but how we can write the SQL queries. So for example, I have the employee data frame, and I would like to write the SQL queries on top of my data frame. So so here my data frame is already, I have created the data frame at the top. So in order to write the SQL queries, first of all, what I need to do is I need to create a temporary view out of it. And so here I'm creating a temporary view, and this is my name of the temporary temp table, let's say. And then we have the Spark session and we have the SQL function. Within that, we can specify the SQL query which we would like to execute. So here what I'm saying is, say, let's start from temp table where ID is equals to 1, and then it will return a data frame, and I'm just showing the result of the data frame. And you could see we got the result. So this is how we can run the SQL queries on the data frame as well. Okay. Now, there are, so first of all, to answer your question, Joy, in terms of the performance difference, there is no performance difference between the two modes, because under the hood, the same code is being created. So absolutely, there is no performance differences. Okay. However, based on my experience, I would say, like, for example, if you're already familiar with SQL, it's good to go with the SQL if you can get around your work with the SQL. And also, if you're looking for some ad hoc queries, you can absolutely go for that. However, building the large ETL pipelines, it might be difficult to use the SQL. So at that point of time, it will be easy to use the data frame API so that you can divide your code into the functions, and you can divide your code into a smaller piece of code, and you can reuse that. So this is based on my experience. However, in terms of performance, no, there's no difference between the two modes.
Okay, cool. Thanks, Niraj. We've actually had a question come in from Ejimo4. I believe I'm saying that right. Apologies if that's incorrect. I believe he was on the meetup last week, so good to have you back. Basically, they've asked, I don't know if you can see that on the right, Niraj, in the chat box. They've basically asked if you don't specify a given join, it defaults to an inner join. Is that correct?
Yes, absolutely. It defaults to inner join. Absolutely.
Right. Okay, cool.
Okay, great. Now, so far we created the data frame based on the dummy data, but this is how we generally don't work in the production environment, and we keep the data somewhere in the different sources. And we discussed in the last session that Spark won't store any data. For that, we need to use some other storage So first of all, we will discuss how we can read some of the Hive tables, and then we can save back to the Hive tables. So what I did is I have already created some Hive tables, so I can show you. Let's see if I can show you the Hive shell. Otherwise, I can show you in the notebook itself. But
Okay.
yeah. Okay. So I'm on a Hive shell, and if I do show tables here, so I could. I mean, the reason is like we have some of the Hive tables already created, so that we can use during the session. Now, what I will going to do is I will going to load my customer Hive table as a data frame. In order to do that, how we can do? So we have a Spark session, and then we have the table function. Within the table function, we can specify the name of the table which we would like to load. Now here, I'm just doing a sorting and limiting just for because this particular table has a lot of records. So I would like to limit only to 100 records, or let's say even 10 records. And why I'm doing a sorting based on the key column, so that every time when I run, I just wanted to make sure that I would only display the top 10 records just for the consistency. So that is just for the demonstration point of view. Now, so this is how my top 10 records looks like, and this is what some dummy data I have used. Okay, now you could see I'm using to display from the Jupyter Notebook. However, if I would like to use the show function, I can do that, but you could see it will be a little harder to follow since we have the multiple columns. So that is the reason I'm using the Jupyter way of displaying the data, because it looks a little neater. Okay, now we have loaded the data frame. So you have loaded the data from the Hive table, and how to process the data, which we have already seen at the top. You can select, you can filter, you can join, sort, create another columns. That is something which we have already discussed on the top. Now you have loaded the data, you have done all the transformations. What next? You would like to save your data as a Hive table, because you can't keep the data in Spark. You have to save your data somewhere. So let's try to save the data back to Hive. So how we can do that? So name of the data frame, then we have a write and the save as table function. Within that, you can specify the name of the table which you would like to save, and you can specify the various modes like overwrite, append, depending on how you would like to save your data. For now, we would like to override our data. So first of all, let me execute this. Okay, so now we have saved our data frame as a Hive table, and the name of the Hive table is customer_10. Okay, now let's check some of the metadata of this particular table and see how it looks like. Now, so this is like DSC formatted name of the data frame or the name of the table. It's just to display the metadata of the data frame. Now there are a few things which I would like to highlight here. First of all, creation time. If you look at the creation time, so it's in the UTC time zone. So we could see it's literally just now we have created. Okay, because we have saved our data frame as a Hive table. So this is something which we have created just now. The second is the type. Since we haven't specified any type and we have stored the data frame as a default Hive table, so the Hive tables are like two types of Hive table. One is the managed Hive table and another one is the external Hive table. So by default, it will store the data as a managed Hive table. Okay.
So what's the difference then between the Hive managed and an external table?
So the major difference between the Hive managed and the external table is if you delete the managed table, for example, this one, the data and the metadata will both be deleted from the Hive. However,
I see.
If we would have created the external table, which we will see in a minute, in that case, if you delete the external table, only the metadata or the definition of the table will be deleted. Your data will still be there onto the storage.
Understood. Okay.
Yeah. So for example, if you have created a managed table and accidentally you have deleted your table, everything is gone. However, if you have external table, even if you have accidentally deleted that table, your data will still be there. It's only the definition got deleted.
Okay, cool.
Okay. Now, for example, if you would like to create a partition table. Then how we can do that? So you can specify the expression partition by, and you can specify the list of columns based on which you would like to specify the partitioning, let's say based on the year, month, day, and so on. You can specify the columns. Here, I would only like to do the partitioning based on the year, and the data frame is saved. The name of the data frame is customer temp part. Now, again, I would like to show the metadata of this particular table just to demonstrate certain things. First of all, the creation time. Yes, this is something which we have created just now. Manage table, because by default, it creates the manage table.
Yeah.
And if you look here, we have another section, partitioning information, because this is the partition data frame. This is the partition table. So we have the partitioning information section where you could see it is partitioned based on the birth year column. Okay.
So that would be the benefit then of using partition table as opposed to a normal Hive managed table.
Okay. So the first of all, for example, let's say you have 1 year of worth of data and you have did the partitioning based on the months. Now, if you don't have the your data partitioned, and if you would like to select a data for a particular month, then what it will do is it will go through the entire data for a particular year and it will extract the data. Right. However, if you have done the partitioning based on the month column, then what it will do is it will go to that particular month and it will select the particular data. So it will reduce the search space. So consider you have let's say a cupboard where you have, let's say, a few sections. So you have put your stuff based on some categories. Let's say your books, your crockery, your play stuff, and something like that. Now, if you don't have these sections, in order to identify a particular thing, you need to go through all the items. However, if you have put like this, and if you need a particular book, then you will only go to the compartment of the books, not to the crockeries or your play games.
That's a good analogy, Niraj. I like that, and it makes sense.
Absolutely. Thanks, Joy. So, and also, if I would like to show you the partitioning information for this, so you could see, let's say, if you have the data for these many years, so it will create the partitions like this. And also, if I would like to show the partitioning details for the table, which is not partitioned, which we have created at the top. So you could see it will throw an error that show partition is not allowed on the table that is not partitioned, because here this table is not partitioned. So that is another way of demonstrating that this particular table is not partitioned. Okay. Now, the next one is the external table, how we can create the external table. So in order to create the external table, everything stays the same. It's just that we need to specify the path explicitly where we would like to store the data. So here I'm using the Google storage. So I have specified some path where I would like to store the data. So let me execute this. And as soon as this will be executed, the next thing which I will again display the metadata. Now, few important points to note. The creation time, yes, we have just created this. Since we haven't specified any partitioning information, we don't have any partitioning section here. And the most important point is this. Now the type is not managed, it's external. Okay, so this is how we can create the external table. Okay, now in the interest of time, I will quickly go through this CSV section. So for example, if you have the CSV file and you would like to create a data frame, or rather I would say you would like to analyze your CSV file in the Spark. So you have the CSV function. Within that, you can specify the name of the path of your CSV file, the separator, header, and a few other options we have in the CSV function to process the CSV file. And so let's say I have loaded that CSV file, and let me just print the schema of that particular CSV file. So I could see these many columns are there in this particular CSV file. However, if you note at the data type, you could see all the columns are of string data type. And I believe this is something which we are not expecting. For example, year, we are not expecting year to be a string, rather it should be some number. So when you read the CSV data, by default, everything will be a string. However, we have a parameter called as an info schema, which is by default false. You can make this as a true. Then what it will do is it will infer the schema automatically. And now you could see we have year and month and the other columns as an integer as well. And even the date as a timestamp. So in order to infer the schema, you can say info schema is equals to true. Okay. So this is how you can read the data from the CSV file. Now, once you got the data frame, it's absolutely similar. You can perform the various operations which we have discussed so far at the top. And let's say once you are done with all of your transformation, all of your processing, you would like again to save the data. Now, even if you have read the data as a CSV, if you want, you can save the data as a Hive table. Okay. Or if you want to save the data as a CSV, you can still do that. So you can say write.csv, specify the location where you would like to save your data, then the separator which you would like to use, header, and like mode, override, append, however you would like to do. And you can save your data like this. There is another way. So here we have inferred the schema automatically. If you want, you can specify the schema explicitly as well. That is something I will share a reference at the end for my blog. You can refer to that, and you can also see how you can specify the schema by yourself as well. Okay. Now, similar to the CSV file, if you would like to work with the Parquet files, so you have a Parquet function. You can read, you can specify the location of the Parquet file, and it will create a data frame. You can display the data like this, or if you like to write your data frame as a Parquet, you can use the Parquet function under the data frame writer. Okay, so this is how you can work with the various data sources which is provided, which is supported by Spark. Also, if you would like to work with the relational tables like the MySQL, DB2, or the Oracle, you can read the data from those relational databases and you can write the data back to the relational databases. As of now, I don't have any, let's say, MySQL database running. That is the reason I'm just sharing pseudocode here. However, so what you can do is you can say Spark read, and you can specify the format as a JDBC. Then you can specify the JDBC URL. And typically, your JDBC URL contains your name of, so this is how your JDBC URL looks like. The JDBC, the subprotocol, which is, let's say, the MySQL, or then the name of the database, the name of the server, the port, and all those information. So you can create the JDBC URL for your database, and then you can specify the name of the table, your username, password, and if you say load, it will load the data for that particular table into Spark as a data frame. And once then you can process your data. Once you are done with the processing of the data, in a very similar manner, you have the save function, and you can save the data back to the relational table. So this is how you can work with the relational tables as well. So this is something which I would like to discuss with respect to the different data sources. Just one last bit which I would like to discuss. Although Spark provides a lot of different functions for us to use ready-made, however, we always have a necessity to write some sort of user-defined functions based on our based on our business needs and the requirements. So how we can create the UDF? So let's say I would like to determine the quarter based on the month. So what I did is I have created a simple Python function, so in which I will just ingest the month, and based on the month, it will determine the quarter. Now, how I can use this particular simple Python function as a UDF? So first of all, I need to register that as a UDF. So UDF is the function which we have imported at the top as a part of the function module. Inside that, you can specify the name of the function, which is the determined quarter in our case, and the second argument is the return type, which is the string. So this is how we can create the UDF. So now we have created the UDF, and the name of the UDF is quarter. Now how we can use this particular UDF? So we can use the with column to create another column, and here we can use the quarter UDF, and we can specify the month column. And when I display this, you could see corresponding to our month, we got the quarter. So month 12 is the quarter 4, month 4 is quarter 2, month 9 is quarter 3, and so on. So this is how we can create the UDFs based on our requirement, and this is how we can use here. So, and at the end, I have some reference links for my blog and the official documentation of Spark as well. So, just a quick minute, I will walk you through this particular blog, because this particular blog will similar to what we discussed today. So at the top, we discussed the basic data frame operations. Then we discussed like how we can do a select, dropping a column, aggregations, sorting, derived columns, the different type of joins, how we can execute the SQL-like queries, how we can work with the different data sources like Hive tables, CSV, and so on, the relational tables. And also, I have a few more blogs, a little more information. So I like just in a minute or so. So this is the GitHub link. Let me show you. Okay, so here is the part 3, in which I have discussed the advanced data frame operations like the broadcast join. This is something which you can use to improve the performance. How you
I think your
can use
connection might be a little bit struggling a bit there, Niraj. I'm not too sure if that's me or you. Can you hear me okay, Niraj?
Right, the UDF. Okay.
Can you hear me okay, Niraj?
Can you hear me? Yeah, I can hear you. Can you hear me?
Yeah, I can now. Yeah, it just broke up for a little bit then. It seems like it's sorted itself out now.
Oh, okay. Fair enough. Is it okay now?
Yeah, it's fine now. I'm not too sure if that was me or you, but something was glitching.
Okay, no worries. I can just say that again in a minute. So in this particular third series, I have discussed the broadcast join, which can be used to improve the performance of your joins. Then the caching, another way of improving the performance of your ETL pipelines. The SQL expressions, so you can write really complex SQL expressions. Here, UDFs, which we have already discussed, working with the null values. So we have a few functions which we can use to work with the null values. The partitioning, because it's important to understand like how the data is partitioned and how we can use. And at the end, we have the catalog API, which is basically to play around with the metadata of the Spark. So I mean, I will share the links of these blogs, and definitely you can go through it as per your convenience. So yeah, this is what I would like to discuss for today. So I would again like to thank everybody, and now I'm open to any questions.
Excellent. Thank you very much for that, Niraj. Yeah, really good, really insightful. I'm sure everyone else thought the same. We've got a few questions coming in. A few of them we've already answered as we've gone through, and we've already discussed. So we've got just shy of just under 10 minutes. So we'll get through a few of these questions. So Yao Ramos, he's asked, can he use that function in different notebooks? I think we might have mentioned that at the start, actually. But go on, I'll let you carry on with that, Niraj.
So you can use the functions in the different notebooks, but the different notebooks have a different way of sharing the notebook. So the idea is what you can do is you can create a Jupyter notebooks where you can create the functions, and then you can execute that Jupyter notebooks in another notebook. So that is one way of doing it. So yes, it's absolutely possible to do that.
Okay, cool. The inner join question, we spoke about that earlier, didn't we?
Yeah.
Are there any precautions while using UDFs that you need to take?
Yes, absolutely. So what the community's recommendation is, we need to use the standard functions which is provided by Spark as much as we can, because they are tested, they are verified for the larger loads, and they are optimized. So if we can use that, definitely we should use that. That is the first preference. But let's say for the business needs, you would like to create your own functions, then definitely you can consider using the UDF.
Cool. I've got one here. I noticed you mentioned this actually briefly just on the blog that you showed us. How do you deal with null values?
Yeah, so dealing with the null values is something like I have shown you in this particular blog. So we have certain functions like is null, is not null, fill any to replace the null values. So yeah, like we can go through this particular section. You can go through this particular section at your own pace, and you should be able to.
Okay, fantastic.
Figure it out. And also, corresponding to each blog, I have the GitHub notebook as well, which have.
I don't know if that's you or me, Niraj, but
examples.
It's breaking up a bit there. Sorry, can you say that again? Okay. I'm not too sure. I'm really not sure if that's you or me, to be honest. But I really couldn't hear you then.
Okay, no worries. I can repeat that. So in order to work with the null values, we have certain functions like is null, is not null, fill landing. Drop and to drop, and it will be, I believe, nicer to have understanding of dealing with the null values. Also, at the end, I have also like shared the link for the notebook as well, which you can go through it, and it has examples of how to deal with the null values with some data sets as well. So I believe that will be a good exercise to go through. So yeah.
Yes, fantastic. And we did have so all the recordings. Wasim's asked us if we can make this session available. Yeah, absolutely. So all of our recordings with Niraj and past guests can all be seen on our YouTube channel, which you can find via the meetup page, Orbis Connect or Orbis Consultants on LinkedIn. And everything's on there, or you can follow me. I'm constantly sharing stuff. And we'll send you links out to Niraj's social media as well, his GitHub, his LinkedIn, his blog as well is on Medium. So, and Niraj, you're happy for people to reach out if they've got any questions, yeah?
Yes, absolutely. I'll try to answer any questions they might have.
Yeah, okay, cool. I've actually just got one last question come in from Alex. Can Spark connect to different databases other than Hive and perform same operations that you've explained? Good question.
Absolutely, that's a good question. So here in this particular section, that's what we covered. So you can use, you can connect the Spark with the relational databases as well. And this is pretty much the skeleton of it. So you can use the JDBC URL, and then you can connect to the different data sources. Yes, absolutely you can.
Perfect. Okay, cool. Yeah, so we just had another comment come in, Moya. Yeah, all the recording will be accessible to everyone. We'll put out links on our meetups, my LinkedIn, Orbis Consultants LinkedIn, and everyone can watch these back and all of our past episodes as well. And on there, just on that point, you can keep up to date with all of our future events. We've got quite a few exciting things lined up. So yeah, get onto our meetup page, Orbis Connect, to find out more about that, and our Orbis Consultants LinkedIn page, or follow me on LinkedIn. I'm always sharing all of our events. So yeah, Niraj, thank you very much again for joining us. Second week in a row. Really enjoyed the last 2 weeks. It's been really insightful for myself, especially, and I'm sure it has been for the people that have joined us as well. So yeah, thank you very much.
So yeah, thanks Joy, and thanks everyone for joining this particular session. Just would like to share one more information. I mean, if you find it useful. So I have written a few more blogs as well, for example, on the Spark window functions, because I believe even when I started working with the Windows function, it was not really straightforward to work with that. So what I did is I have created a separate blog, so you can see the code, and you can see the images and all those things. So I try to explain the different Windows functions what we have into the Apache Spark, which is basically for specifically for the window functions. Then working with the complex data is not always easy. So I have another blog working with the JSON data into the Apache Spark. So if you are interested in working with the JSON data, you can follow this particular blog on how we can work with the JSON data. And the next one is working with the datetime function. So we have various datetime functions, but sometimes it's difficult to follow a particular datetime function because we don't have enough examples or how it works. So in this particular blog, I have created a sample data frame and explained all the functions available till date with some small examples so that we can know what is the input and what is the output for these. And another one that maybe coming in a week or two, that is specifically on the array functions, because with the Spark 2.4, Spark released quite a lot of array functions, which is the complex data type. So it's not always easy to work with the complex data types. So I'm in process of publishing another blog which will specifically talk about the array functions which you can use in Spark. So yeah, stay tuned. You can follow me on the here to look at the more content and the more blogs on this.
Absolutely. You've been very busy, Niraj, by the sounds of it. Again, we're running out of time now, guys. So yeah, just like to thank you again, Niraj. Thank you everyone for joining us, and we'll see you soon. See you later, Niraj. We'll catch up soon, yeah?
Yeah, absolutely. Thanks everyone. Thanks for your time.
Excellent. Cheers, guys. Bye.